So for lab 3, I'll be talking about the black hole. And first of all, this is our table of contents. I'll be introducing the lab and its purpose, and also some equations and principles that we could use to find the data we were looking for or modifying the glow script code, and then the observed data from our initial glow script code, and then the new code. We're going to be discussing that. And then lastly, we're going to be answering the discussion questions and concluding overall. And what is the purpose of our lab? So, our purpose is to estimate the net force components from tracking the motion of a star orbiting a black hole, and all of this to determine the mass of the black hole. And our initial information is that the mass of the star is 2 to the power of 30 kilograms. And then using the initial information, we were able to compute these Fnet, parallel and perpendicular for the components, and then the total Fnet. And so the fundamental principles that we're going to be using are the Newton's second law. And here I've spread it into different components. It's two components, F parallel and F perpendicular, as you see, and then I've found the derivative, which then adds to this equation here, dp, its value times phat, and here as well. And so for the instantaneous rate of change of momentum, we were able to compute the derivative as well. And it all adds up that dp divided by dt, the parallel component, plus dp divided by dt, its perpendicular component, all add up to Fnet as well as from this formula. And so what we know is that p present is parallel to the change in momentum, the parallel component, and the parallel component of the change in momentum, it indicates that an object is slowing down or speeding up, while the perpendicular indicates that a body is changing its direction, and this is how we find the vector of Fnet. And to find the new Fnet, we need to multiply an Fnet by t, as we see in the figure here. So this is the initial glow script code. I added my email address, and this is the pretty much what the glow script code produces, the initial values that we're giving, and we're going to be discussing the code. So we have here g, gravitational constant, the mass of the star, and delta t, which is the change of time, which was then calculated as to be 1 day. And then here, this is the x and y component of velocity, and this is pretty much how we calculate it. And then in the while loop, we calculate the change of those for the x component of velocity and y component, and this is pretty much computed by using delta x and delta t. And here, for it's the same thing pretty much, just using delta y instead of delta x. And for this while loop, we are going to find the v initial and v final, which are computed by these formulas using the vector of those. And then to find the momentum of the initial momentum of the celestial body, we're going to be using this pretty simple formula, p final, using the original equation, mass times v. And then here is the same thing, the change, pretty much using these values to find the change, and then it all adds up to Fnet equal to dpt. And here we use all these values, we plug them in pretty much here, and then out of these we estimate dp dt perpendicular, which is equal to the total minus the parallel, and then we have Fnet is equal to the perpendicular component. And so this is how we estimate then the mass of the black hole. So the formula for the gravitational forces is pretty clear, and we have we pretty much use the formula, but then make it in this form, so it calculates the mass of the black hole. Pretty much, you can see Fnet here, R here, and so this is the modified code. As you can see, the pink arrow represents Fnet perpendicular, Fnet parallel is represented by the blue arrow, and then the orange arrow represents the total force, which always points towards the black hole, as it's obviously experiencing the gravitational pull from it. And so we're going to answer how are the net force and its parallel and perpendicular components different from the rate of change in momentum. So pretty much what we know is that the perpendicular component has a direct relationship to FNet's change, um, while delta T and FNet have an inverse relationship. And so that's pretty much how these two are different from another. It each has a different relationship to FNet. And is it possible to find a value? No, it's not possible because we would need a change in momentum for that body to determine the new net force. And just simply the new mass will not help us. And thank you for your attention.